We are given that the heater of an electric kettle is made of a wire of length L and diameter D. It takes 4 minutes to raise the temperature of 0.5 kg by 40 Kelvin. And then you replace the heater by another heater having wires of length L and diameter 2D. So this is an electric kettle, so the heat will be generated by dissipation through the resistance. I square R or V square by R will be the formula for power. And in the next case, we have the diameter has become 2D, so the resistance will change. The material is the same, the resistivity is the same, but the resistance will change, and that will of course change the power given, and that will ultimately change the time taken to heat the water. So the first equation which will be used will be Q is equal to ms delta T. The total heat supplied, delta Q, will be equal to 0.5 into S. We can put in the values, but even if we don't, we just need the ratios, so it won't matter anyway. 0.5 into S into delta T, which is 40 Kelvin. Right. So this is 20S. 20S is delta Q. What is the power dissipated? We can take that as V square by R. Right, where R is the resistance of the wire and V is the potential difference across the two ends. So that can be written as V square by R we know is rho L by A, so rho L by pi D squared, which is the area. This is the power, this is the heat required. And so what is the power that is required? That is delta Q by delta T, or in this case delta T1, which is the initial time, which is 20S by 4 minutes, which is 240 seconds. I'll just not write the units, it's confused with this S. So 20S by 240, that we are told is equal to V square pi D squared by rho L. Okay. Now this equation can be written as, just to get the values of the constants, rho Ls by V squared pi D squared is equal to 240 by 20, that is 12. Now in the next two cases, here the resistance was rho L by pi D squared. In the next two cases the resistance will be different. So we have two wires, each having length L and diameter 2D. So the resistance of each of the two wires will be rho L by 4 pi D squared. Actually, you know what? D is the diameter, not the radius. So this should be pi D squared by 4, which is the area, right? Pi R square is the area when R is the diameter. But since we need the ratios, it's not going to matter much. So I'm just going to use pi D squared now, and we can assume that D for us is the radius. There's just a difference of a factor of 2. I hope you don't get confused by that. Right. So rho L, we'll just take pi D squared, which is proportional to the area. Right, it's the constant times the area, the constant will cancel anyway. Rho L by 4 pi D squared is the resistance of one such wire. In the first case, we have two such wires in series. That would mean the total resistance R in series is rho L by 4 pi D squared plus rho L by 4 pi D squared, or 2 rho L by 4 pi D squared. In the second case, R parallel, you have both of them in parallel, equal resistances. So the net resistance is half of that, right? 1 by R plus 1 by R is 2 by R, the inverse of that is R by 2. So half of rho L by 4 pi D squared, that is rho L by 8 pi D squared. Now we need the time taken to raise the temperature by the same amount, so delta Q will be the same, and that means delta Q by delta Ts will be 20S by delta Ts, which has to be equal to V squared by the resistance. Earlier it was rho L by pi D squared, now it is 2 rho L by 4 pi D squared. Right. So from this what we get is, we just take this 4 outside for a second, and it's 2 outside, so 4 by 2 will cancel and give me a factor of 2. And we know rho Ls by V square pi D squared is 12. So this gives me 20 into 12 is equal to 2 delta S, which means delta S is 120 or 2 minutes in series. In parallel, you can do yourself. There's an 8 over here, so there'll be a, instead of there being rho L by 4 pi d squared, we'll have rho L by 8 pi d squared, and there'll not be a factor of 2 here. So instead of 2, here will be a factor of 8. Instead of 2, we'll have 8 here. So the answer will be divided by 4. You can do it for yourself. So it will be 0.5 minutes in parallel. So the answer is B and D. Thank you.